may not, but I did. All right, so we got one more example to do, but let's remind ourselves what the normal probability density function or the Gaussian is. And that tells us that f of x is 1 over sigma radical 2 pi e to the negative x minus mu squared over 2 sigma squared, and only the sigma is squared, not the 2 there. And remember that mu is whatever the average or the mean value of the distribution is, and that sigma is the standard deviation. Sometimes we would say the standard deviation of the mean, and that has to do with how spread out the values are. If you have a small sigma, that means you have a narrow distribution. And we wrote down yesterday a bunch of different percentages. So we said that 68% of the area is on 68% of the area under the curve will lie within sigma of mu, 95% will lie within 2 sigma of mu, and 99.7% will lie within 3 sigma of mu. Okay. And then we did one problem that was kind of plug and chug, and like I said, we've got one more to go. Okay. All right. And of course, if we want to find the probability of something, we're going to take the integral between whatever our interval is of f of x dx, and that'll give us the probability of our event or our value or our choice occurring. Okay. So let's do that last journal problem, which is number 31. If somebody would read it for us, please. Yep, in section 8.5. Okay, so let's just stop there. Okay, so they're giving us some information here. So what is that 63.4 inches? And what symbol do we use for the mean? Mu. Okay, and then that 3.2 inches is what? The standard deviation, and the symbol for the standard deviation is sigma. Okay, so we know that we can put that into that formula for f of x and come up with an expression. So part A wants the proportion of female adults, and I'm just going to call that P because I'm going to get tired if I have to write out proportion of female adults every time, or adult females. So we want to know what proportion is less than 63.4 inches tall. Now, what's 63.4 inches again? The mean. And what does the mean mean? It's the average. But how do you find that? Well, what does average mean? Okay, so I add up all the values, and then I divide by the number of values I have. But what does it mean? What's its significance? Yeah, but what's the significance of average? Nope, it's not most common. It doesn't have to be most common at all. If I had 0, 0, 50, 100, 100, what's the average? And that value only turned up once. No, 68%. That's very not technical. What? Let's talk for let's do this. What's the difference, for instance, between mean and median? So again, if I gave you what would be the median value? 70 would be the median. You know how to figure out the mean, right? So what would the mean of that be? You'd have to figure it out. So you'd have 100, 200, 295, 345 divided by 1, 2, 3, 4, 5, 6, 7. You can do it faster on your calculator than I can do in my head. So how many values are less than that? And how many values are more than that? What if I added another value in here? What if I added in a 20? Now what's the mean? The median would be different. I totally agree, but that's not my question. I want an even number of values for a reason. $54 point what? How many values are smaller than the average? How many values are bigger than the average? What does the average mean? Yeah, that's exactly what it means. So I redirect you back to number 1, or part A, which says what proportion would be less than the mean? 50%. You'd get the same answer if you went through the whole thing with the equation, but seriously, we've already discussed how that equation is ugly. And do you want to have to use it more than you have to? No. Okay, so Priya's moved on to part B. What is, no, that's okay, because we're ready. What does part B say? Okay, so how are we going to find that P then? Yeah, we're going to have to plug it in. Okay, so we're going to take, let's get F first. Okay, so F of X is going to be 1 over sigma, which is 3.2 times radical 2 pi, e to the negative x minus the average, which is 63.5, that thing squared, divided by 2 times, again, sigma, which is 3.2 squared. So you're going to have to put this into your calculator and use numerical integration. Okay, you're going to. So, what so? It is. It's still gross. But let's at least try to make some things into decimals so it'll be easier. So for instance, what's 1 over 3.2 times radical 2 pi? What decimal will that be? Let's put a couple more sig figs in there. All right, we'll go to there. Kind of a reasonable number of things to write down. Okay, and then we've got e to the negative x minus 63.5, that whole thing squared. Can't do much about that, but what's 2 times 3.2 squared? Okay. And then, if we want to find that proportion between 63 and 65, we integrate this whole f of x thing between those values. And again, I would use fn int. And you might want to bring the 0.1247 out of the integral, which you can do. So what's this going to give us? What do others think? Maggie's still pushing buttons. Get it? Okay. Maddie, Priya. Okay, Priya got it. Maddie, how you doing? Still pushing? Okay. All right. So part C then says what? What does part C ask us for? Taller than 6 feet. So what's the first thing you have to do? Okay, so how many feet are in, sorry, how many inches are in 6 feet? Okay, so we've got 72 inches. But when I do my integral, I have to have an upper bound on my integral. So what's a reasonable upper limit for my integral? It's taller than 6 feet. You can't really. Infinity would be, yeah, no. I'd go a little higher than 7 feet. Sure. Okay, and 10 feet would be what, 120 inches? Okay. And if you were smart, you'd hit like second entry or something on your calculator and go back and just change the limits of your integration instead of typing that whole thing, if that's possible. Zero 0.4%. Okay. Okay. Because it's 0.004 See what other people get. Okay. And what's nice about actual physical situations is that you know what the upper limit is. You know there's not going to be someone that's infinitely tall. You know there's not going to be somebody that's 10 feet tall. So that's a good upper limit. Okay. All right. So last part, D. What does part D ask us? Okay. So what's the first thing I'm going to have to do? Okay, 5 feet is equal to 60 inches. So that proportion is going to be my integral from 60 to 60 of f of x dx, which you know without even getting out your calculator is equal to what? 0. Which is a place where this breaks down, but the whole point of a normal distribution is it takes all values from negative infinity to positive infinity. So the probability of having any one answer has to be vanishingly small because it measures the probability for every answer. How could you figure out how many people were 60 feet tall? I'm sorry, 60 inches tall. What would you do? No, because that's not what that formula is. That formula has to be integrated. Yes, you would go ever so slightly below and ever so slightly above. So you do 59.99999 and 60.000001. Okay, and you should get a percentage that way. And we'll see what Zoe gets, and then we are done with chapter 8. What'd you get, Zoe? 14%. So if we go slightly below to slightly above 60, we get 14%, which is probably about right. Oh, I'm sorry. Oh, yeah. Okay. All right. So messed up there. So let's see what she gets. Still? Okay. Well, I'm not really going to worry about it. I wanted you to see this. Okay. So thus ends chapter 8.